So the session is recorded. I hope everyone is fine for today and get ready and prepare for the quiz for tomorrow. So in Ivan 32 we have numerous libraries, right? Wherein we actually looked into the libraries, including the calls, the CRLF, the DAM registers, what else that we were actually using or used before. What else? What libraries can you remember from the previous codes that we were using or we were writing? Hello. Hello.
Right hex.
Yeah, it's fine. Let's continue. It seems like you guys are on go slow. So you'll watch so I'll do the talking, and once I'm done with this chapter, then we'll conclude it. Yeah, but this slide won't be posted online after you'll be posted after tomorrow when you're done writing the quiz. So yeah, so we have the call or calling Ivan 32 library. So in Ivan 32, we actually call each procedure using the call instruction. Some procedures you can use, as you can recap from yesterday, requires an input argument. So they include directive copies in the procedure prototype declaration. For example, the following example in 1, 2, 3, 4 of displaying 1, 2, 3, 4 on the console, you can see that we have the include Ivan 32 that. So it means that is an input argument that we have. Hello.
Yeah, we cannot see your screen, sir.
Or you can't see my screen.
Yes, sir.
Can you see my screen now?
No. Yeah, now I
Yeah, so
can.
I'll say yesterday when we departed, we said we would be doing these libraries. So calling Ivan 32 libraries procedure. So we know that from yesterday that in Ivan 32 we call each procedure using a call instruction. Some procedures they actually require some argument. They include directive in Ivan 32. It actually copies the procedures prototypes. So in the following example, you can see that we want to display what 1, 2, 3, 4. So you can see that the input is 1, 2, 3, 4 hexadecimal, and then hence we say to show the number, we can say call write hex. So when you're saying call write hex, it will show you the number or show the hexadecimal number. And then when you say call CRLF, you're actually doing what? You're saying, usually saying, I want the end line. So library procedures overview. So you can see that you have what you call the close file, the CRSCR. You have the create output file, the CRLF, the delay, the dump mem, the dump register, the get command tail, get date, get max XY, get seconds from or milliseconds, and then get text color, go to XY, is it a digit? So display a message box or a message box either when you ask or, and then we have the open input file, the paste decimal 32, the pies integer 32, the random 32, and the randomize, and the random range, the read char, the read des, the read from file, the read hex, the read int. So you know this one of reading from here, when you're reading a char, it means you are actually inputting something or asking something from your keyboard. Read from a file, read from hex, read int, read key, read string, set text color, str compare, str copy, str length, str trim, str ucase, and then wait message, write bin, write bin, write char, write this, write hex, write hexp, and write int. So as we can go back from it, so the close file in IVN32, this procedure closes a file that was previously created or open. So the file is identified by what we call the IVN32 handle, which is they are actually passed to either one of the registers. So if the file is closed successfully, the name is returned in whatever register, and or the value that will be in the register, either EAX, EBX, will be non-zero, right? And then you have the CLRCSR. So this one, it clears the console window. This procedure is typically called at the beginning and at the end of the program. So if you call it, if you call it at other times, you may need to pause the program by first calling wait message, which is this. So we have another one, which is create output file. So this one, what it does, it creates a new disk file and opens it from or for writing. So if you call this thing, what happens is that it places the offsets of the file name into register EDX. So yeah. So another one is CRLF. I believe that everyone knows it, which writes the end line of the sequence to the standard output. And we have what we call the delay procedure, which pauses the program for a specified number of milliseconds. And then we have the dumb mem. So I know you guys are familiar with dumb registers. So the dumb mem procedure, this one, it writes the range of memory to the console window in a hexadecimal. And then we have again the dumb registers. So this one, it does what? What does the dumb registers do? What does the dumb register do? Or dumb rex? Anyone? Am I audible?
Yes, sir, you are.
So I'm asking what does dumb registers do?
Displays the content that is in the um, general purpose registers.
So this one, you know, from the previous one, it displays the procedures or I mean the registers or displays the registers, namely the EAX until the EDX, and it will show you the ESI, the EDI, EBP, ESP, and EPI, and EFL. And then after that, it will show you the flags, which is the zero flag, the sign flag, the carry flag, the overflow, and what again? Hello? 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 Which flags will be printed by the dam registers procedure?
Zero flag, overflow, carry flag, and
Yes, the magazo. Okay. No, those ones we spoke of them. So so we also have the what you call the get command tail. So this procedure copies the program's command line into a null terminating string. So what happens is that if the command line was found to be empty, the carry flag is set. Otherwise, the carry flag is cleared. And then you have the get date time. So what it does is that it gets the current date and the time from the system. The get max xy, this one gets the number of calls rows in the console windows buffer, and we have the get milliseconds. So this one return milliseconds elapsed since midnight. We have the get text color. It returns active foreground and background text color in the console window. Go to XY, it locates the cursor at row and column on the console. Is digit, it set zero flag if AL contains an ASCII code for decimal digit 0 to 9. And then we have the MSG box and MSG box ask. This one display pop-up message boxes. And then we have the what we call the open input file, which open existing file for input. The parse decimal 32, it converts unsigned integer string to binary. And the parse, we said decimal, this is the parse integer 32, which converts the signed integer strings to binary. And then we have the random 32, which generates 32-bit pseudo random integers in a range from 0 to FFFFFF. And then we have the randomize, which seeds the random number generator. And then we have the random range, which generates the pseudo random integers within a specified range. And then we have the read char, which asks the user to input or reads a single character from standard input. We have the read test. It reads 32-bit unsigned decimal integers from the keyboard. We have read from file, which reads input this file into the buffer. And we have the read hex, which reads 32-bit hexadecimal integers from the keyboard, and also the read int, which reads 32 signed decimal integer from the keyboard. The read key reads characters from the keyboard input buffer, and read string from std in terminator by you terminate it by actually end. So if you write something, if I'm writing right cell Muhammad, then if I want to terminate it, you have to enter the enter key. And then we have the set text color, which set the foreground or background color of all subsequent text output to the console. We have string compare. This one compares to string. String copy. It copies a source of string to destination string. String length. It returns the length of the string in AX. And string trim. It removes unwanted characters from a string. And then you say string U cases. It converts a string to upper cases. Wait message displays the message, waits for enter key to proceed. So yeah, so if you have that procedure with you, so for it to proceed, you must actually enter. So the right binary, who's that? Sample. I've been asking questions now, but it's fine. Sample. Hello.
As if you say we must write a program to copy a string, and you just use the right string thing, you'll get 0.
Which one?
The string copy.
When you say
Write a program to copy a string from source to destination.
or if I say that, will you get if you use what?
String copy.
So the only problem I told you is it's for you. If I didn't specify that inside the instruction, I'm not that strict when it comes to marking. Ne? But once I mention something in the instruction of the question or somewhere in the instruction on the question paper, so it means there is a specific way in which I'm channeling you to actually come up with that problem, isn't it so?
Yes.
So, but once I didn't mention and you have a certain idea, then it means even if I give you 0, you can still come and fight for or discuss or why did I give you 0 for that. So if that is not the case, then I have to actually give you your full marks.
All right.
Isn't it?
Thank you.
Thank you. So we also have the write bin, which writes and assigns the two integers into ASCII binary format. The write bin B, which writes binary integers in byte, weight, or double weight format. And then write char. This one writes a single character to standard output, and then write it as it writes unsigned 32-bit integers into decimal format. And then the write hex would write unsigned 32-bit integers into hexadecimal format, and then write hex p writes the byte weight or double weight in hexadecimal format, and write in it writes the string, or it outputs the string 32-bit into 32-bit as decimal format. And then we have the write stack frame. This writes the current procedures stack frame to the console, and write the stack frame name. It writes the current procedures name and the stack frame to the console. And lastly, but not least, we have the write string, which writes null terminated string to the console window, and then write to file. It writes the buffer to output file. And last one, which is the write Windows message, it displays most recent error message generated by MS window. So this is the first one, which when you want to clear the screen, the delay program, the delay program for maybe how many minutes? They say 5,000 millisecond, and the dump registers and flag. So you can see that you said call CR as CR. So what is CR as CLR as CR does? Anyone? Hello. So to go back, this one we said it clears the console window. So it will clear the console window before that thing runs, and then from there you moved 5,000 into EAX, and you say call delay. So, and then when you say call dump registers, before the dump registers can be called, you are actually asking them to say, I want this thing to take 5,500 millisecond to delay. So that will be your sample output. So moving forward, this is how you display a null terminator string and move the cursor to the beginning of the next line. For example, you say string 1, you initialize string 1 to an assembly language. It's easy, comma 0, that is a null terminating string. So you just move the offset of that string number 1 to EDX and say call write string, and after that you say call CRLF. So that is what you've been doing in the entire. So yeah. So if you want to display an alternating string and move the cursor to the beginning of the next screen line, you can use the what? You can use what? You can use either the embedded CR, LF. So yeah. So I believe that everything that is done here was done before. So yeah. So okay. So now I'm gonna give you a sample question so that you can do it and we'll discuss it. I'm gonna post it on the chat quick. All right. Oh, please, I'll give you 5 minutes to complete it. Hello guys. Malaji. So let me just say this example, just to be specific. Make sure that you do them as homework. If you want to see them, you'll come and check these recordings. Do these examples as homework. Do them all as homework. So because this is just calling these procedures, it's not something hectic or something that would actually need more attention for me to start and say, let me show you the code that does this. So try to actually study and check how each and every procedure there works. So in 64-bit assembly language, the 1132 library, you still have your CRLF. It also does the same thing. It writes an end line sequence to the console. You have the random 64, which generates the 64-bit pseudo-random integers. Randomize, which sees the random numbers generator with unique values. You have read in 64. You have read in string, and then you have the string compose can compose to string in the same way the CMP instruction does. And we have the string copy, which copies the a source string to target location. You have the string length, which returns the length of the null terminator string into the accumulator register rex. And then we have the write int 64. It displays the contents in the rex registers as a 64-bit signed decimal integer. And then we have the write hex 64, which displays the contents of rex registers as 64-bit hexadecimal register. And then we have the write xp, which displays the contents of rex registers as 8-bit hexadecimal register. And the last one, which is the write string, which displays a null terminated ASCII string. So yeah, so that actually concludes. But most of the time, this on this module, we just introduce the 64 bit what do you call 64-bit instruction procedures, but they are not actually being assessed, but make sure that you do them. So yeah, so that actually concludes our today's class.